In this segment, I'm going to be continuing work on the text boxes. So these are the graphics that I worked on a little bit off camera. While I was developing last time, one of the things I realized was that it would be really easy to draw these boxes if I made text box tiles that I could just stretch. I could render really wide or really tall, not necessarily stretch vertically and horizontally at the same time, just in one dimension. I think I'm going to have two kinds of text boxes. We'll have a text box that's kind of standalone. I'll just paint it somewhere onto the screen. It has no attribution, has no association with an entity or a tile or anything like that. It just has some fixed position. And the second kind of text box will be something with attribution. So it'll be like this first text box where it will have otherwise mostly square borders, but then it will have some a little arrow pointing to an entity or a tile or something like that. Since the last visualization, I have since changed the font in use. The text box is automatically resized. I can show it resizing by changing the font again, rebuilding, and then rerunning. I added some alpha to the background color of this box so you can kind of see through it a bit. So I could change this, for example, to 18 point. The text is now larger and the text box has automatically resized. In what used to be the simple game update procedure, I have just implemented inline all of the text box handling stuff. So we will pull this out. I'm thinking of making a new module called UI, and I'm going to pull out all of the text box stuff and put it into the UI. I realized something. I created a primer string, but what I did not do is actually render the string. So we created a text object, but there's no way to really prime the texture cache unless we actually build textures. And to my knowledge, we need to actually render the string in order to build the texture cache. Render text off screen on the first frame to prime the SDL3 TTF glyph cache. So we're going to render at the XY of the logical screen dimensions, which means that we'll put it off screen. And we see no observable change in behavior, which is great. That's exactly what we want. So I consider the glyph cache primed. I should probably have a top level, like an encapsulating call that's just render text. It'll take in text string, and then it will do all this logic. I guess down here we will just say UI.render text at, and we will render foobar at X of 50 and Y of 200. We will need to pass in GS text object or new platform renderer. So after the renderer, I pass in the text box tile set, which I was saying was game state text box. That builds, and we still run and render. Cool. So we have factored that out into the UI module. But there's something that bothers me here. The player is really sharp. If you look at the font here, the rendered text is blurry. And so how do we make this crisp? One of the ideas that I had, I actually confirmed accidentally by poking around in the bindings documentation. As mentioned in previous recordings, I'm using set render logical presentation. That's one of the reasons why I get auto letterboxing. But one of the things I found here when reading about set render logical presentation is this one paragraph. You can disable logical coordinates by setting the mode to SDL logical presentation disabled. And in that case, you get the full pixel resolution of the render target. It is safe to toggle logical presentation during the rendering of a frame. Perhaps most of the rendering is done to specific dimensions, but to make fonts look sharp, the app turns off logical presentation while drawing text, for example. It's unfortunate to have read that. However, I was also thinking the same thing. The only way we're really going to get super crisp fonts, if we are like rendering text on the fly, is to actually turn off logical presentation or perhaps rescale logical presentation. Maybe keep logical presentation on, but just change the scale factor for a moment. I'm thinking of another function, another entry point, which would be render text attributed at, or something like this, a similar signature, which does not take an XY, but it takes an attribution tile. The player's position would be the attribution tile. The tile above the player would be drawn the little attribution texture, or the part of the texture, and then equal, not really to scale here, but equal on both sides would be some like half width of a text box, and then we just kind of draw something similar like we did here above the player, but the math is a little bit different to get the alignment correct. We can probably crib a lot of this here. I'll probably write something similar, I'll duplicate a lot of it, and then we can look at the commonalities and probably consolidate the render text at into a single routine. So text destination is, yeah, we need to compute this dynamically. Even if I passed in the actual tile, not what we attribute to, but one Y step up from that tile, we would still need to convert to tile indices and then go to screen pixels from the map library. So we'll probably just pull in map for now. We'll do the logic out here first, just to get the implementation of this guy correct. Render attributed text at. I like render text attributed at. Let's make an overload of this, which will allow us to pass in a math vector. So we'll call world tile to screen pixel here in game. So this is not what we want to see. However, we're getting closer. All right, we're drawing our hello text in front of the player. We need to attribute it to him though. So we can tell some things already, right? So the first thing is that we cannot see the bounding box around the player, but in fact, the player does not occupy the entire tile. The player kind of fits into a 16 by 16 tile. So the 0, 0, when I convert the player's position to screen pixels, we're getting this guy back, this top left corner here. So if we go back to the game, we can see that indeed the text, the SDL has I guess assumed some padding for the text, which we did see earlier, some vertical padding. But if you look at the guy's head, he has 1 pixel between his head and the top of the tile. So if you go 1 pixel up and then come over here, SDL kind of, I guess, assumes that this point right here is 0, 0 for the player tile. The text is drawn top down from that point. So we actually need to shift this over a bit, right? We need to center it. But another thing that we need to do is we're going to be adding the little attribution guy at the bottom here. And what I would like to have happen is that there is at least 1 tile on the left of the attribution pointer and 1 tile on the right of the attribution pointer. So we now need to deal in terms of tile widths for the text box, and we need to enforce a minimum tile width. And I guess the minimum tile width is 3. I guess we basically center the text. That would probably be most natural, just centering the text over the player. And if we do center that whole thing, then the number of tiles needs to be odd. Yeah, so we have a render text box guy here, which already has most of the logic for what we need. We just need the attribution, and then we need to do the centering and whatnot. I might just duplicate this, patch what I need, and then maybe off camera I will consolidate these routines, these procedures. So technically we need to pass in the player position -1. Dot y is going to be a minus equal 1. Why was I trying to do entities in Game Drive 169? Positions. And so now it's a little bit above the player, but we need to move it up even further. And I think this might be 1 text box sprite tile. Attribution graphic. Or here, I'm going to do something super scientific. Render text box 2. And we're just going to make the modifications and render text box 2 that we need. And then I'll think about the refactoring later. Drawing the bottom border is going to be different. This is why I don't want to muck with render text box. This is why I want to duplicate it. We need to know the attribution position, and we do know it right here. I can just hack this real quick. The source is going to be in the atlas here. So this is going to be the text box TS, and this is going to be the trib index. The destination is going to be the tile screen pix XY. And we will render with our renderer, our text box TS atlas, source detail, our source destination. Okay, so this is what we got here. Destination Y position, we subtract the text height, but we also need to subtract 1 times the text box tile set dot tile height pixels. And it's not quite right. Okay, so yeah, we can kind of tell here that the drawn border here, that's not aligned on a tile boundary. But then down here we pad the height. I think that's what it is, right? We're adding height padding in here. Actually, I don't think we need to pad anymore. This was when I was not stretching the tile. So now the text box is a lot tighter. Padding actually does give some nice visual properties. I might want to go back and add some padding. But now you can see that this looks to be a rounded tile. Now the spacing is fixed, but the problem is that I am drawing the attribution tick over another border here because I've just left in the logic in the render text box guy to draw the bottom border. Now let's center the graphic. We do need to shift the text destination to the left a little bit. This is the test destination X plus, I guess we can just do this twice here, right? So plus and then minus. This is going to be our text box T. Whoa. Technically, we want to shift by half of the player tile. All tiles in this game are the same size, so I'm making logical distinctions, like in my own mind, mental distinctions between map tiles and entity tiles and things like this, but technically everything is the same size. I don't quite like how I'm mixing that up so much, but we'll just deal with that for now. Text box, es.tile width pix. We're going to add half of this divided by 2.0. Hopefully that auto casts. And then what we need to subtract is the text width divided by 2. So that is now centered over us. So we have the X and Y correct, but the thing that is not really working is this attribution guy here because it's being drawn over part of the border there. In order to fix that, we have to do more coordinate mucking because we first need to extend the width of the text box to be evenly divisible by number of tiles, and then I want to make it odd. So we just do an even check and then we add 1 in order to make it odd. The drawing of the text box is based on, or is relative to, the position of the text. Now that the text is centered, we can start mutating the width of the text box itself. Okay, so padded dimension. We're going to have the text dimension, which is the base size. If there is any remainder after dividing the tile dimension into the text dimension, we are going to add that, and that's going to bring us up to a whole number of tiles. So now we know we are a whole number of tiles. So padded dimension is going to be some pixel dimension, and then the tile dimension is also pixels. This is going to give us the number of tiles in the padded dimension. And if that happens to be even, then we are going to add the pixel width of a tile to the padded dimension, and we will return padded dim. Now we're getting warmer. We actually have 2 tiles on each side. Remember that the border tile is actually a lot of empty space here. A lot of empty space. Let's go to black. A lot of empty space with a little border on the right-hand side. And then the same thing for the left-hand, the right-hand border. The left-hand side is the border and the right is mostly empty space. So we have kind of a 1 tile here. We have 1 tile here. And then we have 1 tile here and 1 tile here. In the middle, it's going to be reserved for our pointer guy. Okay, so the bottom border is going to work a little bit differently now. We are no longer going to be stretching. We're first going to get the number of tiles. If I did that thinking correctly, we divide in the tile width into the padded width some odd number of times. That's guaranteed by the padding that we did previously. And then we subtract 1 from that to make it an even number. And we divide that by 2. That's going to give us the number of tiles on either side. And then the number of tiles on one side plus 1 is where the attrib tile goes. We can just do this a little procedurally, right? We can say for, initially it will be 0 to side num tiles minus 1. We draw left bottom border, and then manually, not manually, but outside of a loop, we will draw the attribution graphic, and then we will draw the right bottom border. And this will be for side num tiles to I guess side num tiles times 2 minus 1. So we can get rid of the minus 1 here and rely on integer division. If we make this, let's see, cast to, I guess just an S64. Okay, boom, cast S64. So we don't need a minus 1 here anymore. Yeah, from side num tiles to odd num tiles, minus 1. And here's what we do for the bottom border. We have the bottom index right here. So the source is always going to be bottom index and blah, blah, blah. The destination is going to be the text box body X plus the iterator times the textbox tile set, tile width and pix. Y is always going to be the same. The width is always going to be the same, and the height will always be the same there. So that will take care of the left-hand side. Now, if I run this as is, we should see an incomplete bottom border, and we do not, because why? Yeah, the destination is padded with pix. That is not the case. We are tiling, so the destination, this is not the destination, this is the width. This is just going to be our tile width right here. We will build this. Okay, so we now have half of this when we draw the attribution graphic, no longer a hack. So we get source rect in atlas, the attrib index, yada, yada, yada. Now here, we're basically just going to copy the dest here. Copy this dest. So attrib tile is going to be this guy here, attrib tile times the width. Okay, this is wrong. We're off by 1 here. Yeah, we count from 0. So that's the off by 1. So that's now fixed. And we duplicate the logic one last time for the bottom right corner. We'll just go take the left corner here and yoink that. Side num tiles, we are duplicating that here. So it's going to be side num tiles plus 1, I guess. Okay, so we fix that. But yeah, we have this padding issue here. Oh, it's not tile aligned with the player because we did shift by half a tile. So we need to shift to the right by another half a tile. What is the padded width px? 52. Yeah, that's the issue. Something went wrong in our padding. My logic was wrong in the maybe pad text dimension. I do not add the remainder, if there is any. I add the difference of the tile dimension and the remainder when dividing the text dimension by the tile dimension. Without further ado, we now have attributed text. We can attribute it to a specific tile, and it's over the player here. The rest of this stuff is really just cleanup. It's just consolidating the duplicated code that I made. Thanks so much for tuning in. I hope you guys enjoyed watching some Jai programming. Build cool things, have fun, and have a good rest of the night. Peace.